Okay, these are the notes from chapter 2.1, and we're going to look at the functions of acute angles. Now, in the previous sections, we used angles in standard position to define the trig functions. There's another way to approach them as ratios, or the lengths of the sides of the triangles. So we've done one way, which is dealing with the angles, and then this one is the length of the sides that we're going to deal with, and then we have a third one coming up. It's called the unit circle. So you've done this before. When you have a triangle here and you have a right angle, this is called a leg, this is called a leg, and the angle from across is called the hypotenuse. Okay? You've had that before. That's nothing new. Now, it could be labeled angle A, B, C. And C in this case is the right angle indicated by the little square, and it's across from the right angle. Now when you're looking at these, we're going to talk about what it's talking about here, the side opposite from A and the side adjacent from A. The way I remember this is that angles think they rule the universe when you're dealing with the triangles. So we're going to look at this a little bit more. So angle A, if you go directly across and look at this leg is called the opposite. Okay, it is now called the opposite. And then the leg adjacent to angle A is now called the adjacent. Okay, the adjacent. And we do that to help you identify some different things. And instead of using R, like we used when we were dealing with the distance formula between the origin and a point in the coordinate plane, R is now simply just the hypotenuse. It's simply just the hypotenuse. And that's where these functions come from, okay? That is where these functions come from. We're talking about sine A is y over x, is what we've had in the past. Let me draw the triangle again. So if we have A, B, and C, and you're looking for sine of A, A's here, so it's opposite over hypotenuse, okay? And then cosine of A is adjacent over hypotenuse, and then tangent is the side opposite over side adjacent. Now we left in these notations here that you've had in the past. So we left that there so that you remember. Now you had a way that you remembered before, and you probably had it. It's called SOHCAHTOA. I don't write mine that way. I write it this way, and I remember it a little bit different. And I write it this way because it helps me remember what goes on top and what goes on bottom. And the way I remember it is simply, some old hippie caught another hippie tripping on acid. And by using that, that helps me remember what goes where and how it works. Now, if you can get these three here, if you remember, these are simply just flipped. Okay? They're simply just flipped. So don't forget about that. So when it says to find the sine, cosine, and tangent values for A and B in the right angle in figure 2, this is what we're going to talk about. So what I do is, let's look for sines of angle A. So I'm going to highlight A first, and I'm going to go, okay, this is the opposite side. This is the hypotenuse side. So that means that this is the adjacent. Remember, your hypotenuse is across from your right angle. So sine A is going to equal 7 over 25. Cosine, let me write that a little better. Cosine A is going to equal 24 over 25. Remember, cosine is the adjacent side over the hypotenuse. And then tangent is simply, whoops, let me write the A again. is 7 over 24. Now, I'm going to change the colors, and we're going to look at blue. Now, when you do this, your adjacent and your opposites are going to change. This is now the opposite because we're dealing with side B, and then this is your adjacent. Okay, so we're dealing with the adjacent. So let's see if we can look at sign B. So sign B is going to be 24 over 25. It is the opposite over the hypotenuse. Cosine B is going to equal 7 over 25. Tangent B is going to equal 24 over 7. Now, can you look at a couple of things and see if you can tell anything? Look at let me change my colors a little bit. Look at sine A and cosine B. They're the same thing, aren't they? Well, let's stop and think about it. If you have one 90-degree angle, which they showed us here, that this is a 90-degree angle, then sine A and sine B are acute angles, and they would have to add up to 90 degrees because we already have 90 degrees indicated by the symbol. So the other two have to be 90 degrees combined. So they are complementary of each other. They are complementary of each other. So that's what's important, okay? So that's where we get these cofunctions identities. These cofunctions identities. Now be careful. These are where your cosines, your cosecant, and cotangents come in. And they are different than the reciprocals that we just discussed on the previous page. So be very, very careful. So when you're talking about sine A, when we're looking for the cofunction identities, so what it says is that it's cosine, and it's going to be 90 minus whatever A was. Okay? Cosine, remember these are reciprocals, cosine and sine. I mean, not reciprocals, sorry, these are cofunction identities. So again, if you're looking for cosine of A, or if you're looking for the cofunction of cosine of A, you're going to take A away from 90 degrees, and then you're going to find the sine of it. Okay? Don't forget, we're going to practice these. Again, this is cosecant and secant, and then you have tangent and cotangent. So the directions here say, write each function in terms of its cofunction. Write each function in terms of its cofunction. So if we do that, we're going to look at cosine of 52. So cosine of 52 is going to equal sine of 90 minus 52. So cosine of 52 is going to equal sine of 38. Now if you punch that in the calculator, make sure it's in degree mode, and you're going to they will balance each other. They would be the exact same thing. It didn't ask what it was, it just said in terms of its cofunction. So we're going to leave it at that. So let's look at B. So tangent of 71 equals cotangent of 90 minus 71 degrees. So tangent of 71 equals cotangent 19. Write that a little better. Okay, and then the last one, we're going to do secant. We're going to do secant, and you get secant (24) equals cosecant of 90 minus 24. So secant 24 equals cosecant of 66. Now when you go to punch these in the calculator, it's pretty good. The problem A works really well. You have to punch that in. But problem B, when you go to punch in problem B, tangent works just fine, but when you go to punch in cotangent, you need to punch in 1 tangent of 19. And that will make that work. Okay? And when you do secant and cosecant, you're going to have to punch in their inverse functions too. You're just going to have to play with the calculators to help you with that. Okay, this one is solving equations. It's the same trig functions on both sides. We just have to think about what we're looking for, okay? The same trig functions. So let's look at this one. We need to get them the same. So this says cosine, and this one says sine. It doesn't matter which one you would want to change. You just need to change them to look alike. So I'm going to change them both to sine. So I'm going to change the first one. Sine is going to be 90 minus parentheses theta plus 4. All I'm doing is plugging this in, equals sine of 3 theta plus 2. And those are degrees. You have to distribute that negative sign through, so you're going to get 90 minus theta minus 4 equals sine of 3 theta plus 2, again in parentheses. So sine of 90 minus 4 is going to be 86 minus theta equals sine of 3 theta plus 2. And it's at this point you can drop the signs. So now you're going to get 86 minus theta equals 3 theta plus 2. You're going to do your algebra. So we're going to add theta both sides. So we get 86 equals 4 theta plus 2. We're going to subtract 2 from both sides. So we get 88. I'm sorry, we're going to subtract 2. I added 2, didn't I? So I'm going to get 84. Let's rewrite this. 84 equals 4 theta. We're going to divide both sides by 4. And when we do, theta is going to equal 21. So that's for A. Let's go and look at B. Okay? And you can change either one, but I'm going to change the one on the right. So now you have tangent. If I can get my pen to work. Tangent of 2 theta minus 18. I think I need to give myself some room, so let's erase. And let's erase all the work on this one to give us some room. I had to make my eraser bigger. Again, we're going to be working on B so that we can get it taken care of. Okay, so we're going to look at B, so we get tangent of 2 theta minus 18 equals, and we're going to convert this to tangent. So now we're going to have tangent 90 minus, and make sure you open up a set of parentheses, theta plus 18, close parentheses. And we're going to do tangent of 2 theta minus 18 equals tangent of, again, you got to distribute that 90 through that negative through there. 90 minus theta plus 18, close parentheses. So now you get tangent of 2 theta minus 18 equals tangent of 72 minus theta. So I'm going to drop the tangent, so now I have 2 theta minus 18 equals 72 minus theta. I'm going to add theta to both sides, so I get 3 theta minus 18 equals 72. I'm going to add 18 to both sides, so now I get 3 theta equals 90. And when I get 3 theta equals 90, then I divide by 3, so theta equals 30 degrees. So that's what it was wanting us to find, all of those types of things. Now the next thing we're going to talk about is dealing with the special right triangles. And these take a little bit of figuring out. If you have a 30, 60, 90, you just need to memorize some things. So, for example, across from 30 would be considered a 1. 30 is smaller than 60, so 1 is there. Across from the hypotenuse, across from the 90 is a 2. And across from 60 is the square root of 3. 90 is wider than 60. 2 is larger than the square root of 2. And so these are the special right triangles. So we will have to find the trig functions of those at some point when you start looking at these. They make a little bit of difference, okay? And then when you have a 45, 45, 90, that means the legs across from the 45s, both of them are going to be the same. And again, we don't use r, but the across from the right angle is the square root of 2. Okay, across from the right angle is square root of 2. And here's the way I remember them sometimes, to remember where the square roots are. Because 60 and 30 are divided by 2. Can be divided, they can be divided by 2. But they are multiples of 3. I remember that we have the square root of 3. And because this is dealing with an isosceles triangle, I know that the two sides are the same, and so I look at it this way. And so that's the way I try to remember it. So let's talk about the trig functions of those two. When we're talking about the trig functions of those two, and we have our triangle, so let's start with our first one. We have 30, 60, and 90, and then we have 1, square root of 3, and we have 2. Remember, we're just going to find the first 3. You can find the others. So let's do sine of 30. So sine of 30 is opposite, which is 1, over hypotenuse. Okay? Cosine of 30 is adjacent, square root of 3, over 2. And you don't have to change it because we have the radical sign in the top, so we're good. And then tangent of 30 is, remember, some old hippie caught another hippie tripping on acid, so it's opposite over the square root of 3. That square root of 3 can't be there, so you have to rationalize, so you get the square root of 3 over 3. Okay? So let's look at the 45, 45. Okay, let's do sine of 60. So I have sine of 60. Remember, it's opposite over hypotenuse, so it's going to be square root of 3 over 2. Then we have cosine of 60, and it's going to be adjacent, so it's going to be 1 over the hypotenuse. And then the last one is going to be tangent of 60, and it's tripping on acid. So remember, it's opposite square root of 3 over 1, and this is simply just square root of 3 because it's over the adjacent angle. Screen. So here's our 45, 45. So if we have 1, 1, square root of 2, and these both are 45. Sine theta of 45. Oh, I need to go back to the other slide. Let's go back real quick. Okay, we went back and fixed that one. Let's finish this one. And we only have to do this once because the angles are going to be the same. So opposite over adjacent is, opposite over hypotenuse is going to be 1 over the square root of 2. Remember, you have to rationalize that, so you get 2 square roots of 2 over 2. Then cosine is adjacent 1 over the hypotenuse, and it's going to be the same thing. So these are going to be pretty easy to remember. Then tangent is opposite over adjacent, which is 1 over 1, which is simply just going to be 1. So there's all of our trig functions for our special right triangles. This ends the section on 2-1.